Sample problem 17.8. The solubility of calcium sulfate, CaSO4, is measured experimentally and found to be 0.67 grams per liter. Calculate the value of KSP, solubility product, for calcium sulfate, okay? So the solubility is grams of the solute, of the salt, the compound that we're interested in. The number of grams, the mass, that dissolves into a liter of solution. So in a sense, this is like sample problem 17.7, but working backwards. We're, instead of going from KSP to solubility, we're working backwards from solubility back to KSP. So here's the trick to this. Take your mass, 0.67 grams of calcium sulfate. That's how much dissolves into a liter of solution. The trick to this is to convert it to moles per liter, okay? So what I'm going to do is I'm going to multiply this by a ratio that involves the molar mass. So calcium is 40.08 grams per mole. Sulfur is 32.07. And 4 oxygens would be 64. So that's your calcium, your sulfur, and your 4 oxygens. Okay, so it looks like this is a 15, it looks like this is a 6, and it looks like this is a 13. So 136.15 grams per mole. That means that it's 1 mole of calcium sulfate for every 136.15 grams of calcium sulfate. So the grams cancel and you've got moles per liter. So that's the first step, is to convert it to moles per liter from grams per liter. So 0.67 divided by 136.15. 4.9 times 10 to the minus 3. Let's go ahead and leave the extra sig fig. 4.92 times 10 to the minus 3. Moles per liter. Now here's why we want to do that. This is the molar solubility. That's S. So now, if we write out the equilibrium expression for calcium sulfate, we're doing KSP, right? So that would be calcium plus sulfate. And so what happens is, initially these are 0 before it dissolves. Some of it does dissolve, so you get plus S. So at equilibrium, these are S. So here's what's happened. By doing this conversion up here, we figured out S. So we know those two values. The expression KSP is the concentration of calcium times the concentration of sulfate. Well, that's just S times S. So it's S squared. In other words, that number squared is going to give us our KSP. So for this particular problem, it's just S squared. So it's 4.92 times 10 to the minus 3 squared. So I'm going to go back and take that number that we just calculated and square it. And there you go. 2.4 times 10 to the minus 5. Now I'll round it to 2 sig figs. 2.4 times 10 to the minus 5 is our KSP. Okay? So not that bad. If you take a look at, they don't actually give, actually if you look in the table 17.4, they'll tell you calcium sulfate is 2.4 times 10 to the minus 5. That's the value of KSP. We just figured it out. We got it. Okay? Working backwards.